In this video, we will learn how we can add physics bodies to our node so that they are affected by gravity and able to interact with other nodes. Again, we want to start with our spaceship and assign a simple physics body to it. I can do so by setting the physics body property of the sprite node. So let's write my first textures sprite node dot physics body. And now we are able to initialize a physics body to physically represent the spaceship in our scene. I have a lot of different initializers to choose from, but I will now stick with the most simple one, which is circle of radius. It is a literal circle with a given radius. I want to pass half our spaceship's width or height for the radius so that the body is about as big as the sprite itself. So therefore I'm going to write my first texture sprite node.size.width divided by 2. And I have now already added the physics body to our node. Let's run the app and we should see a circle around our spaceship, since in the beginning in our debug information properties of the SK view we have defined that we want to draw the physics bodies. We will also see that gravity will play a mean prank on us by instantly pulling our spaceship into the abyss, but see for yourself. As soon as the app pops up, we were briefly able to see the physics body of our sprite, but then gravity happened and pulled our spaceship downward. Since we do not have any form of physical ground in our scene, it will fall indefinitely and never stop falling, and is already way out of our sight right now. However, we can easily fix this by adding an edge physics body to our scene itself. Since our scene also is an SK node, we can just assign a physics body to its physics body property. So let's write physics body, which is the same as if we would have written self.physicsBody for the physics body of our scene, and then initialize a new SKPhysicsBody for it. This time we will choose edge loop from CG-rect. This will create an edge from a certain rectangle, and we will of course just pass the scene's frame property, which will conveniently build a physics edge right around the edges of our scene. We can already observe two important things here. First, for our spaceship, we have chosen a volume-based physics body, since we want to interact with other bodies and be dynamic. For our ground, however, we have chosen an edge-based physics body, since it does not need mass nor volume, and it doesn't need to be influenced by other bodies. What this means is that when our spaceship plummets to the ground, it will bounce back slightly, but our ground will remain static and not be pushed down by the impact, which would really make no logical sense at all, but after all, we're just talking about a spaceship falling down. So, never mind. Let's run the app again, and our spaceship should now land safely on the ground of our scene. The app started, and we can observe what happens. Our spaceship was again pulled down by gravity, but it stopped as it hit the ground. We bounced back slightly, which is alright, but our ground stayed in place, just like it should, since it has an edge-based physics body. If we take a close look at the edges of the screen, we can also see the lines for our frame physics edges. Let's have a look at what properties of physics bodies we can play around with here, and even take a look at the physics world property of the scene, where we can change the gravity, for example. I can completely manipulate what forces should be applied in my scene, and I can do so by writing physics world, which is the property of the scene, and then appending .gravity to set the gravity to a custom vector of type CG-vector. A vector will take two arguments, which represent the force in x and y direction. X means to the left and right, and we usually do not have any gravity forces there. However, we can change that by defining negative 1.0, for example, which is a light force pulling everything with a dynamic physics body to the left. The dy value is negative 9.8 by default, which should represent Earth's gravity. I will decrease this by a little by defining negative 2.0 to simulate a more, let's say, spacey environment for our spaceship. Let's run the app again and see what happens. We can now see that our spaceship slowly drifts to the bottom left corner, where it bounces off a little bit and then stops as soon as it finds a position where the forces pull directly against the ground. Let's change two more properties of its physics body to change the behavior slightly. We can see that it rotated a little here, and we might not want that. I can easily prohibit this by writing my first textured sprite node.physicsBody, and then I can add an exclamation mark to that because I have actually initialized the optional property physicsBody. So I can explicitly unwrap it here and then add dot allows rotation and set it to false, which will keep our spaceship straight. Other than that, I want to say my first textured sprite node.physicsBody.restitution and set it to 1.0. The restitution of a physics body defines how much energy is retained when colliding, and therefore how far we bounce back when colliding. Setting it to the max value of 1.0 will hopefully result in a longer moving phase of our spaceship as we bounce off the ground a lot further now. Let's take a look. Our spaceship doesn't rotate anymore, and we can clearly see the difference in the energy retention. We don't want to look at every other property now. Just like for actions, I've created a small document with everything, so you can look it up, and I want to encourage you again to play around a little bit with it to get a better understanding of how these physics bodies work. To finish this lecture, let's do another quick challenge. Why don't you try to add a physics body to our blue box as well, so that it also can participate in the physics simulation. Pause the video and give it a go. Okay, I'm pretty sure that everybody completed this task, and now let's have a look at how I would do it. We would do blue box.physicsBody and set it to a new SKPhysics body. And we can of course use the circle just like with our spaceship, but I want to use a rectangle of size, since it will be a better representation of the shape of our box, which is also a rectangle. As the size, I will just pass bluebox.size, which will fit perfectly. If I run this again, we can see our blue box participating in the simulation and colliding with the ground, as well as with our spaceship, which already results in quite some bodies bouncing around in our scene here. Again, play around, use other physics bodies, change the gravity and other properties, and if you run into anything you do not quite understand, feel free to ask us and we will be more than happy to assist you and help you out. Physics bodies and the general concept of physics simulation is an important part of most games, so we should be pretty confident in using them and understand the underlying concepts pretty well before we start creating our own game.